For this teaching worksheet, the objective is to see a variety of problem solving that involve negative numbers. So sometimes this kind can also be known as the real world context. So in all your topics, they try to infuse some real world context. So here are some examples. They are the typical one that I'll be discussing, and all the division rules, all the things that you already learned about negative numbers can be incorporated here. Okay, so what you will require is you have to be very patient to read a chunk of words. Okay, so if you read example 1, chemicals X and Y are both stored in a freezer at -7 degrees Celsius. Okay, so there are two chemicals and they are at -7 degree. So in part A, there is an experiment for chemical X, and they are heating the chemical X until the temperature rises by 12 degrees. So please read carefully. Rises by 12 degrees. That means you're going to increase a 12 degree to the current temperature. So what you will need to do will be something like you must know that chemical X starts from -7 degree. So when you are heating it, right, you are increasing the temperature. So eventually, now you are going to get a new temperature. Okay, try to label your working. This is called label. So I label what I want to find, then I do my working. So essentially, right, I'm going to add a 12 degree to it. So if you look carefully, right, that means essentially it's the same thing like you have learned in the second teaching worksheet. So here you will be doing like 12 minus 7. So it grew to a positive 5 degree. So from -7, now it become like 5 degree. Then for part B, we are cooling chemical Y. So chemical Y is also starting at -7 degree. So when you cool down, right, that means you are subtracting. So the temperature fall is like you are dropping it. So you are subtracting it. So now my new temperature will be -7, and you continue to -15. Continue to drop it even further. So in a way, this one will look like the -7, -15. So here you will become even more negative. So that is the new temperature. Okay, in the last part, your job is to calculate the difference. So in the last part, your job is to calculate the difference between the two final temperature. So whenever you see difference, right, we know that we are doing a subtraction. You must have the idea that when you do subtraction, it's big minus small. So between the two final temperature, you got to see which one is the bigger one. So this is the positive temperature. This is the negative temperature. So the difference will be big minus small. So you are going to use the 5 degree to subtract the negative 2 degree. So that's where you also see this in your second teaching worksheet. You will encounter negative. So remember, the double negative become a plus. So that will be a 27 degree difference. So generally when they do a subtraction, right, we want a big minus small. So pay attention to the units because here is a bit of real world context. So in this question, the unit is degree Celsius. So in some other question, it can be other unit. Okay. So let's look at another question here. This one is a very typical question. You will find this kind of variety in the real world context. So what is this context talking about? If you read carefully, we got a mountain. Okay, so if you want to, right, you can draw out the mountain. Can draw out a mountain. Okay, so this is like the bottom of the mountain, and this part is actually the top of the mountain. So they are describing to you the temperature at the bottom is 27 degrees. That's a bit like our room temperature. But when you get to the top, it became a -3 degrees. So if you visualize, right, as you climb to the top, the temperature gets colder. So that is the challenging part if you try to climb a mountain. The higher is it, you get very cold. So that's why it's quite challenging when somebody can climb Mount Everest or this. It will take quite a bit of effort to get through the difference in the temperature. Okay, so the you must be able to see that the temperature decrease. Okay, so the first part is a very simple question. The first part is the difference between the top temperature and the bottom temperature. So like I mentioned in the first example, when you deal with a difference, it's always big minus small. So you must be able to tell where is the bigger temperature. So this is the big temperature, and this is the smaller temperature. So when we try to do the difference, then you will say something like 27 degrees subtracting -3 degrees. That's where you see the double negative again, and that's where you apply your knowledge of double negative. Okay, so generically, it will always be like this. When you go to algebra, right, we also be doing such a like kind of like subtraction. Okay, so B is the challenging part. So we were told that the whole mountain is 3,000 meter tall. Okay, and you are assuming that the temperature drop per meter height is constant. So what's the meaning of it? That means, right, every 100 meter, we're going to drop by a certain amount of temperature. So it's like a fixed ratio, fixed kind of drop. Okay, so we're going to explore this with this idea of from part A. There's a reason why they ask you to do a difference for part A. So the temperature difference is 30 degrees. So you can do a thinking like this, but don't show your teacher. You can think this way. You can do like 30 degree. You can think in the arrow, idea. Okay, you think in the arrow idea, then it will tell you something like this. So it will tell you something like 100 meter. So this is thinking. Don't show this thinking. But you use the arrow to help you to facilitate the thinking. So what is this trying to tell you? That means, right, every 100 meter that you climb, the temperature drop by 1 degree. Okay, you do something like this, but don't show your teacher, please. Don't show the arrow. But this should facilitate the thinking. So how you can present, right? Okay, when we present, right, sometimes I'll write in words. 3,000 meter correspond to 30 degree. So every 1 degree drop is 3,000 divided by 30. So I'm trying to put my thinking into words. So I'm just trying to put my thinking into words. I don't want to show the arrows. Okay, then what is the question asking? We want to know the height when the temperature is 5 degrees. So we want to know what is the height when the temperature is 5 degrees. Okay, so let's observe. From the bottom, it was this. And then we want to observe how far it will be when the temperature is 5 degrees. That means, right, you also must have the understanding that from 27 degrees to 5 degrees, there is a drop of 22 degrees. So the temperature dropped 22 degrees. That means, right, the height increase will be 2200 meter. So it increased from the bottom by 2200. So the height is this when the temperature okay. So this one, right, they can change it a lot. They can change different mountain, different values. So sometimes the values are not so nice. The next one can be a little bit more tricky. Okay, and I will need to change a little bit of the next question. Okay, so there is a submarine and then there's a helicopter. So this question a bit tricky because some people didn't know that submarine is actually below sea level. So it's something like I have a sea level, and the submarine is below the sea level. It's like a ship underwater. Okay, so I'm just going to draw a rectangle to represent the submarine. Okay, and then there is a helicopter on top. Helicopter is in the air, so it's above the sea level. So the helicopter is 328 meter above the sea level. So this part is 328. Okay, in part A, we know that the submarine, right, is 240 below the sea level. So essentially the submarine, right, the submarine is minus 240 because it's below. So we want the vertical distance. So if you look at the diagram, the vertical distance is quite obvious. How far they are apart from each other. If you do just based on the diagram, you realize that you just need to add. But the vertical distance is also something like the difference. The difference between the two helicopters. So if I think about the difference, it is also like big minus small. The big will be the 328. The small will be the minus 240. Okay, eventually I still end up with the same answer. I got a double negative. I also add up with the same answer. So either way will be okay. Okay, so the next one is also the same, a little bit of the same idea as the mountain question. Okay, so the submarine is going to rise up towards the surface at the rate of 40 meters every 30 minutes. So the understanding will be every 30 minutes, the height is going to increase 40 meters. So the question is asking, what is the location below the sea level after 2 hours? So you need to think about how many blocks of 30 minutes in 2 hours. So in 2 hours, we have 4 blocks of 30 minutes. That means, right, okay, we are going to the height increase. So this will be the height increase. The height increase will be 160 meters. Okay, so you're going to increase the height by 160. So the submarine was at minus 240. The original position was negative because it's the below the sea level. You can think of the sea level as a 0. So below the sea level will be a minus 240. So from the starting position, we are going to add 160 meters. So when I do this, my answer is still negative. That is actually correct because the question says the location below the sea level. So negative 80 is telling you that it's actually 80 below the sea level. So your calculation shows that it's a minus 80. But when you answer the question, you will just answer that the submarine is 80 meters below the sea level. You don't have to answer it as a minus 80 because we are answering it in a statement format. So in the calculation format, the negative is the indication that it's below the sea level. So when I answer it in word, the submarine is 80 meters below the sea level. Okay, so that is how you answer it. So there's a significance when something is negative. So in this situation, the significance is below the sea level. Okay, so these are the variety. There's a lot of variety. The whole teaching worksheet has a lot of questions for you to explore. You just have to be patient to read through the chunk of words and also apply. Of course, don't read wrongly, then you apply the wrong technique.